Welcome to the MWC 2021 Aarna Networks booth. We are a software company approaching 5G and edge computing from a management plane point of view. Our mission is to have zero-touch 5G and edge computing application management. Our open source product, the Aarna Networks Multi-Cluster Orchestration Platform, or AMCOP, performs three things. First, orchestration, then lifecycle management, and finally real-time control loop automation of cloud-native 5G network services and edge computing applications. So what's the problem we are solving? The problem is that the stress on application management explodes with 5G and edge computing. Everything in 5G is software except for the radio. Along with edge computing applications, now you have a large number of applications that have to be spread out across a large number of edge, core, and public cloud sites. With network slicing, the application instances actually increases. And then you have a lot of change. You have termination, slicing, upgrades, reconfiguration, migration, replication, all going on, increasing the stress by about 100,000-fold on application management. So existing techniques are simply not going to work. You can think of orchestration at three layers. There is infrastructure orchestration, which is setting up bare metal servers, installing the operating system, and installing Kubernetes. Then container orchestration, and then finally network service or edge computing application orchestration. We play in that third category. For the first category, we work with partners such as Red Hat OpenShift, public cloud vendors such as AKS, EKS, and GKE. For the container orchestration layer, we work with Kubernetes. And finally, we do the application or network service orchestration. Orchestration is a short form for intent-based orchestration, lifecycle management, and real-time policy-driven closed-loop automation. We draw upon three open source projects: Linux Foundation Networking ONAP, Intel Openness, and Linux Foundation CNCF. AMCOP has three main blocks. The network service or application orchestrator, which is from the Openness MCO project, Edge Multi-Cluster Orchestrator. That's the layer that registers all the underlying Kubernetes clouds. They can be edge, core, or public. It onboards CNFs, Cloud Native Network Functions, or CNAs, Cloud Native Applications. These can be stitched together to form a network service or a composite application based on intent, placement intent, customization intent, network intent. These network services or composite applications are placed to the right Kubernetes cloud with the correct day zero configuration. Next, for ongoing lifecycle management and day one, day two configuration, we use a project from ONAP called CDS along with SDNC. And finally, for closed loop automation, we use a component from ONAP called DMAP, which monitors these applications and makes corrective actions automatically without human intervention. There's a workflow engine on top with a GUI and a REST API layer. There's an Arna Stream Network Slicing Manager on the left, which does comprehensive end-to-end slicing for core, RAN, and transport. And the product is extremely easy to use and compact. Over time, we will also develop the non-real-time RIC for ORAN and NWDAF for 5G core. Now, let's get to the demo. In this demo, we are going to show you how to use public cloud technologies for 5G core. If you are in the Cloud City booth, you know that public clouds are going to take an increasingly important role. So on the right-hand side, we have Azure Kubernetes Service, AKS, which is cluster 1 running on the public cloud Azure, and AMCOP is running on AKS in cluster 1. AMCOP is then orchestrating an open source 5G core, it's called Free 5G core, onto a second cluster. That second AKS cluster can be on Azure, as it is in this demo, or it could be on Azure Stack as well. Azure Stack Hub, HCI, Edge, doesn't matter. And we will show you the orchestration, and then we will show you traffic running through the Free 5G core to the internet. Before we start the demo, both the AKS clusters have already been deployed. AMCOP has already been deployed also, and we are going to start with the AMCOP GUI. Okay, so we are going to the AMCOP GUI first. And here the first thing we will do is to create a project. You can also call it a tenant. So let's call it free 5G and just give it a descriptive name. Let's go ahead and create it. Now the next thing we will do is register a cluster provider, which is a logical construct. In this case, it's Azure Cloud. Once the provider is created, we will register an actual Kubernetes cluster, in this case AKS. So this is cluster 2 because cluster 1 is the cluster that AMCOP is running on. So we are onboarding cluster 2 and importing the configuration parameters. We are showing you how to register one, but obviously you can register tens or hundreds as well. Now we are going to add a network service. So let's call it free 5G core and give it a description. Now underneath that network service, we can add a variety of applications. We can add a number of applications and create what's called service chaining. In this case, we are sort of keeping it trivial. There's only one underlying CNF that we are importing, which is the free 5G core CNF. So we now import the Helm chart. Okay, there we have the Helm chart in the TGZ file. And now we'll also import profiles, which is day 0 configuration overrides. All right, so now that we have done this, we just select the cluster where we want to place it. We select the network. So we provided, essentially we are providing it placement intent and networking intent. And now we are going to go ahead and deploy the service that we just designed. And with a click of a button, we have deployed it. Yep, there we go. And the entire 5G core network service should now be deployed. So now let's go ahead and check it. So we checked the Kubernetes pods and we saw that the 5G core had in fact been deployed. And now what we are going to do is we are going to run a test using a GNodeB simulator. And here you can see the UE ID that has been registered in the free 5G core GUI. We didn't show that operation, but that was done previously. And we are going to try and access example.com. So the first thing we'll do is establish an SCTP connection to the AMF. We'll get the UPF association and the IP for the UE. And we'll go ahead and make the traffic call to example.com, which is successful. Thank you for listening, and if you need more information, contact us by email or check out our website. Thank you.